Okay, this was method one from yesterday. Okay, I used the fact that if you can prove that a pair of opposite sides of a palm are equal and parallel, then you can conclude that the quad is a palm. Okay, that's the theorem that I used. Okay, in actual fact, like a converse of the original theorem. All right. Okay, let me. All right. Can I have your attention? I also want you to be aware that your term one is the easiest for the whole year. Right? So going forward, things are going to become a little bit more challenging. So you have to tighten your belt. All right. So let's go over this question. Now, yesterday, this is how I did using method one. But I want you to be aware that the same question can be done using congruency. Okay? You can do the same question using congruency. So this is how you can approach the question if you are going to use congruency. All right. Here, I'm going to label again the two palms that we are given. Right? So we have A, B, C, D. Okay, remember that line AD is parallel to BC. And then we also have EFCD, that's EFCD, right? And these two are parallel. That is, EF is parallel to CD. Now, the one that we are supposed to prove that it's a palm is AFGE. AFGE. Okay, so yesterday I used the fact that the opposite sides are equal and parallel. Now, I can also prove by using congruency. Okay, if I use congruency, this is how it's going to work, right? Now, yesterday, I already proved this, that AF is equal to FC because the diagonals of a palm bisect, okay? At the same time, ED is equal to FC, which means AF is equal to ED. I already have that from yesterday, but I'm going to rewrite it again today as well. Furthermore, I'm sure you can see this. I hope you can see this. Right? Yesterday, I told you that FC is parallel to ED from yesterday. I hope you can also see that. Because geometry is about what you see. If you don't see it, you won't be able to do the question. Okay? So, FC or CF is parallel to ED. At the same time, in maths, point A, point F, and point C, we call them collinear points. Okay, I know probably you might not have heard about that word. It's a very common word going forward. So because point A, F, and C are on the same straight line, okay, that straight line, it means that if FC is parallel to ED, it therefore means that AC is parallel to ED because FC is part of AC. There is a relationship. So I spoke about that yesterday. Now, this is very important. Since AC is also parallel to ED, it means I can use the fact that there are alternate angles here. For triangle, now you might need to do like probably a construction. Okay, you might need the construction there. So the construction is you can create a point here. Okay, we can call it another letter. Let me call it M. Okay, let me call it point M, where line AD, I can't say diagonal at the moment because I haven't proved that it's a palm. So line AD and line EF, they intersect at this point. So I can call that point, say, M. You can give it whatever name you want. Okay? Once I've named this point here, I'm going to use my knowledge of congruency. Okay? So I'll say, because here I'm going to make the assumption that I didn't do method 1, so I have to start from scratch. Okay? So I'll say AF rather. Okay, I can say AF is equal to CF. And the reason here will be diags of a palm. Diags of a palm. That's my reason there. Okay. AC is equal to C, sorry, AF rather. Sorry, it's not AC, it's AF. AF is equal to CF. Okay. AF is equal to CF. Do you agree with me on that? Right? The reason is because the diagonals of a palm bisect. Because we are told that ABCD is a palm, therefore that's true. At the same time, I'll say AF is parallel to, it's going to be parallel to ED. The reason we wrote it yesterday, the reason for this, right? We have got CF equal to AF. Yeah, AF is parallel to ED because AC is parallel to ED. Okay, so we have got that. I can write it down here. So AF is parallel. This AF here is parallel to AD because CF is parallel to ED. Okay, because of the fact that point A, F, and C are on the same straight line. This is common sense, by the way. Okay, it's common sense anyway. So AF is parallel to ED because I can say because CF is parallel to ED. So my reason there will be CF is parallel to ED. Okay. Now, so I've got my parallel lines there. Now, it is very important to prove that AF is parallel to ED because once you do that, you can then use the fact that they are alternate angles. So let's identify those angles now. Right? If you look at this diagram, if AF is parallel to ED, it therefore means that EF is a transversal. Do you agree with me on that? Also, AD is also a transversal, which means this angle here is going to be equal to that angle. Okay? Also, this angle here is going to be equal to that angle. Furthermore, right, so I've got this angle being equal to that, and this angle here is equal to that angle because they are alternate. At the same time, I also have vertical opposite angles, so this angle is going to be equal to that angle. Right, so I'm going to say, let me start by saying AF is equal to ED, okay? AF is equal to ED because of that. So let me write it down like this, number 1. Okay, rather let me say in triangle, right? In triangle, AMF, okay, AMF, and triangle, so I have AMF, and I have triangle DEM. Right, I'm going to use DEM. What is the objective? Okay, the objective, I want to prove that the diagonals, they bisect. Okay, so I want to prove that EM is equal to MF and AM is equal to MD. That's the objective. So I have to use congruence to do that. So my two triangles that I'm going to identify is triangle AMF and triangle DEM. So this will be DEM. Right? Number 1. I hope you're aware of this, that CF, if I start with AMF, so it will be CF is equal to AF. Right? I've already written the reason there. The diags of the palm, right? At the same time, CF is also equal to DE, And the reason here will be opposite sides of a palm. Do you agree with me on that? Since I've got CF and CF, I can say therefore I've got AF here, so I'll say AF is equal to DE. Does this make sense? Huh? You can talk, because this is your opportunity now. We are seeing each other face to face. CF is equal to AF because the diagonals of a palm bisect. CF is equal to DE because they are opposite sides of a palm. Since CF is equal to both AF and DE, it therefore means that AF is equal to DE. Okay, raise your hand if you are understanding that. Yes. If your hand is down, then you might need to ask before we carry on. Do you have a question? Okay, so I've got this. Then, right, here I just want to emphasize that I made a mistake of labeling this angle here incorrect. It's supposed to be the one which is inside. Okay, so allow me to, in fact, let me leave it like that because if I try to redo it, the eraser won't allow me. So I'm going to change the color and let me use blue. So this angle here is equal to that angle. Okay? Right? And this one here is going to be equal to that. The reason is because AF is parallel to ED. That's the reason. So we have two transversals here. That is AD and EF. So if I can manage to prove that triangle AMF and triangle DEM are congruent, I can say, therefore, EM is going to be equal to MF and AM is going to be equal to MD. Therefore, the diagonals what? Bisect, hence the shape is a part, the quad is a palm. That's the objective. So I've proved that here a pair of corresponding sides are equal. So I've got my A. So the condition that I'm going to use is the angle side condition or side angle. Okay, so number 2. Are you following? Okay, let's move on to the next page. In fact, the other thing as well, when you are answering geometry questions like this, sometimes a construction can be required and it is acceptable. Like what I did here to name this point of intersection as point M. That's why when you write your maths paper 2 in the FET phase, you have got an answer booklet where they'll give you the diagrams, a separate sheet with the diagrams. So on those diagrams, you can do some labeling and all the stuff. Okay. Now again, allow me to add the following information. So let me use this color. Allow me to add this information to make things easier for myself. So these 3 angles, I'll call this one A1, that one A2, that one A3. Right? Also here I'll have E1, E2, and this one will be, now I've got many angles here. So I can call this one F1, F2, F3, F4, F5. Okay? That's also allowed. Okay? Because you'll be given the diagram, so you can label it. Right? This is to enable the person who will be marking your work, like myself or another person, to see what you are doing. Okay? Then at this point here, I can also have M1, M2, M3, and I can have M4. Right? And on the other side, I can have D1, D2, D3. Okay, that's how I'm doing it. You could have done it in a different way from me because we are 2 different people. All right. So once I have this information, it becomes easier for me. So AMF, I'm going to say A2 is equal to D1. Okay, that's the next thing that I'm going to say. So on the next page, I'll say A2 is equal to D1. Well, Can you allow me to do it on the same page to avoid, okay, this is part of the solution. So let me use this color. So I'll say number 2 here, angle A2 is equal to D1. My reason alternate angles. And then I have to state the lines that are parallel. That would be ED is parallel to AF, or you can say AF is parallel to ED. Okay. Another way to name the angles. This angle here, A2, I can call it DAF. Okay? You can call it DAF. You can also call it MAF. You can even call it DAC. So it has got many ways of naming it, right? But I call it this way. Then number 3, I'm going to have F1 is going to be equal to E1. So F1 is going to be equal to E1. This is also important. I'm sure you can see that the way that I'm writing my angles that belong to the same triangle are on the left-hand side. Okay? Or they are on the right, or in fact, they are on the same side. So A2 and F1, they belong to the same triangle AFM. Right? D1 and E1, they also belong to the same triangle. Don't mix the pairs up. Okay? Once you have got this, the reason alternate angles, and AF is parallel to ED. Okay, now you should start smiling. If you are writing a test, your heartbeat will be very calm, you know that you are on track. Right? Then this becomes, therefore, triangle AMF, okay, is congruent to triangle DEM. And your reason, okay, I prefer to write it as angle, side, like that. Now, once I prove the congruency, I'm not done. I'm going to use that to make a final conclusion. If this is true, then I can say, therefore, EM, or let me start with from the other side, I'll say FM is equal to EM. Okay, my reason, it will be congruent triangles. Right, you can also give it like that. Right, it's a shortcut. Those 3 horizontal lines and the triangle sign and the S means congruent triangles. If you want to be more specific, then you specify that triangle AMF is congruent to triangle what? DEM. Right? Furthermore, AM will be equal to DM. And again, the reason is because of congruent triangles. Once I have this now, I can now make the final point and say, therefore, AFDE is a palm. Why? Then you say converse diagonals of a palm. Okay? Converse diagonals of a palm. Right? So it will be converse diags of a palm. Right? You can put the word in full, but I can just write, draw 2 parallel lines of 2 forward slashes and then an M, probably as a subscript if you like to say so. And then you are done. Okay. Like, this is a much longer way. Right? It requires a bit of some thinking to get to a point where you can do it this way. Okay, the method that I used yesterday, method 1, is the shortest. Okay, and to me it's probably the easiest. So this will be method 2. Okay, any question? Anybody who has got a question? from now on, I'm sure you can see it's unfortunate that I don't have enough space. Right? But the layout, how you set it out, and how you write your reasons, you need to make sure that you are familiar with that. If you get familiar with that in grade 10, it will make things for you going forward. Okay.